In this video, I'd like to talk about the concept of formulas and units. So we're going to look at several different problems where you're given a formula and you have to be comfortable using different units and being able to convert from one unit to another. So with this problem, according to Newton's second law of motion, the sum of the forces that act on an object with a mass m that moves with an acceleration a is equal to m times a, or just ma. And this is the famous F equals ma, which you learned in physics. Though technically it's the sum of the forces, so a lot of times you'll see with a capital sigma, the Greek letter sigma, meaning sum. So when you add up all the forces, you get a net force. This is equal to the mass of that object multiplied by the acceleration. So an object whose mass is 80 grams has an acceleration of 20 meters per second squared. So what calculation will give us the sum of the forces that act on the object in newtons, which are given as kilograms times meters divided by seconds squared? So the force of something is in the unit of newtons. And a newton is essentially the mass of an object, kilograms, multiplied by the acceleration of the object, which is meters per second squared. Now, a lot of students get confused since acceleration is meters per second squared, but acceleration is just how much your velocity is changing. So if, say, you're running at 10 meters per second and then you increase it to 15 meters per second and you did this in, let's say, 5 seconds, then your acceleration, A, would be 5 meters per second, but you did that in 5 seconds. So the 5's cancel, and so you get 1 meters per second squared. So essentially what this means is that every second your speed increases by 1 meter per second. So it's a little bit confusing, but when you see meters per second squared or miles per hour squared, that's just the acceleration. It's how much your speed is changing in a given amount of time. So the units for newtons are kilograms times meters per second squared. So this is our acceleration and this is our mass. Because remember, they tell us that force is just mass times acceleration. And so our mass is in kilograms and our acceleration is in meters per second squared. So when they ask which calculation will give us the sum of the forces that act on an object in newtons, so we're looking for essentially the left-hand side here, we just have to multiply the mass in kilograms times by the acceleration, which should be in meters per second squared. Now our acceleration, A, is in the proper units. So A in this case is 20 meters per second squared. But our mass is in grams, so we have to convert that because the units that are always used for these formulas, we call them the SI units, the standard international units. We use meters, kilograms, seconds, and liters. Those are the main ones you're going to use. There are other SI units, but if you're not given your unit in that correct SI unit, you need to convert it. So when you're given grams, you need to convert that to kilograms. So we have 80 grams, and we know that for every kilogram, there are 1,000 grams. And I want to cancel grams out, so I'm going to put grams in the bottom. So for every 1,000 grams, there's 1 kilogram. So essentially, you get 80 over 1,000, which I'm going to leave it like that because you'll see that the answer has that. And so we multiply A times M, or M times A. And so M, we know, is 80 over 1,000, because we converted that to kilograms. And then A is just 20. So we're looking for 80 over 1,000 times 20. That would be choice C right here. So with that in mind, let's keep going. Let's try another one.